have to forgive me. I can't see the talk on my screen anymore. So if I look like I'm not looking at you, which is cardinal sin, not my fault. Is it time yet? Yes. It is time. Perfect. All right. There are actually more people here than I expected, and now's the time where I get to tell some of you maybe to leave, because if you know anything about XS, if you've ever successfully put any code into XS, this is not going to tell you anything. So if you want to go somewhere else, I won't be offended. If not, here we are. I'm Joel Berger. I'm a PhD student at the University of Illinois at Chicago. I just gave a talk about doing some really, hopefully, ridiculous programming. But to do it, I needed to write some wrappers for a C library, and I had to learn both C and XS to get there. This talk is actually going to assume that you know C and you know Perl. It will hopefully all of you know how to build a module that you would release to CPAN. Maybe you haven't actually done it, but you at least conceptually understand some of that. You don't even really need that, but it's the build manager that helps you actually build this XS code. So for now, you guys know Perl, you know C, but XS is this little black box that lets them talk to each other. And you might want to do that to write optimized functions. You might want to wrap some C libraries. You may have other reasons to do it. But what is XS? It's not just this black box. It's C functions and macros provided by the Perl headers that you'll put into your XS file. Henceforth, we'll call that the C API. I should have written that in my talk, but we only discovered that phraseology late last night. And it's also a bunch of XS preprocessor directives. And that's where it gets kind of scary. You haven't seen stuff that looks like this before. It's really useful, but it's not what you're used to. So quickly, what are we going to call a baby language? Well, it's the naive code that new programmers write. It's a simple subset of the language as a whole. It's not necessarily wrong. It's just maybe not the most efficient. You've seen this on Stack Overflow, or if you're helping somebody, or maybe it's you now. It doesn't matter. Maybe you avoid some complicated things like map and grep. You don't make references unless you absolutely have to. You avoid the special variables. But it's really Perl, but it's just not big Perl. So XS is really useful, but it's a lot to learn. So let's talk about baby XS. I'm defining it, but someone else could probably define it better than me. I'm going to say it looks like C, and it behaves like Perl. Think of it kind of that way. You won't be that far off. So these are just going to be some little hints that I'm going to give you. You can do whatever you want, and it actually, well, I'm getting ahead of myself. For now, we're going to ignore a thing called TypeMaps. They're good. You might want to learn about them, but we're not going to talk about them. We're going to use some functions from a great piece of documentation called Perlguts. It orders these functions by kind of what you're trying to do with them, not by alphabetical listing. So use Perlguts if you're like, I wonder how you do this. You can probably do it, and it's probably in Perlguts. We're going to ignore the preprocessor as much as we can. You can actually ignore it just a little bit more, but there are reasons I don't want you to do that. I'm going to suggest that you always use a Perl level wrapper for your C level function. You don't technically have to, but it'll be easier for you at least right now. Doing this lets us avoid things like stack macros, and you want to ignore those for now. And most of the issues of a thing called mortalization, which is really confusing. We don't get to quite miss all of it. We have one case where you still have to talk about it. But all this is real XS. It's maybe not the best XS, but it'll work. And if you want to improve it later, it'll just expand naturally. So in C, we have types. We don't just have this beautiful scalar like we have in Perl, and the other simple data structures we have in Perl. But we have these container C objects. So you have a scalar in Perl. You have an SV star in C. And similarly with an array, hash, reference, all the other stuff, globs, they all have these things. You're probably not going to need those yet. It's also C. So we have ints, we have doubles, we have char stars. I think there's a few others that automatically course, but these are the ones I need. I'm kind of lucky in some sense because I was wrapping a mathematical library. I really only had to think about doubles. And so if you're going to have to return things like objects, there are people that can help you, but it's not me. For future reference, this is where that TypeMap file comes in. If you have something that you want to automatically return, and you want Perl to say, oh, I know how to do that. I'm returning my strange thing, but I want it to automatically pack it into a scalar for me, it can do that, but I'm not going to tell you how. So here is a full XS file. You could write this, and it would totally work. What is it? Well, right here at this line is where XS begins. Everything down here is XS. Everything up here is C, but with those C API functions. And we get those by putting in these 3 lines of standard inclusions. You always need these 3 lines. You basically always need them to be right at the top. There's one little exception, but we're not going to talk about that right now. This also gives you some of your standard C libraries like standard IO and things like that. I tried to find a list of what they were, and I couldn't find it. A little scary. But from those headers down to that XS line that I'll talk about in a second is just C code. Write it like C, use it like C, it's just C. You can use the functions like I told you in Perl Guts, and I will tell you a couple of those. But for now, you can just look and see. I've got a function called meaning. It takes no arguments. It returns the number 42, and that's an integer. And because C and Perl understand integer, that will get packed into a scalar and returned when you call meaning. Greet, you can return void, by the way, and that just doesn't return anything. It takes a string, and it just prints to standard out hello name. Of course, you can do this in Perl, but we're talking about XS. This line tells the preprocessor to start thinking about this not as C, but as XS. And it has module and package. Most of the time, those are going to be the same, and they're also going to be the same as the Perl package that you're going to write. Package, my module, semicolon. Don't really think about this very much. That's just there. After that, this is a little bit of XS code, and you should write this much of XS code. It can do lots more than that, but this is basically just telling Perl how to wrap this into, or C, how to wrap this into Perl. And these are just simple declarations. You can almost think of them as like another header file. They have a little different structure, which someone who's more competent in C just told me that that's more K&R style. If you know what that means, that's what this is. I don't know what that means. So you, on the first line, tell it what you're returning, the type. This might be an SV star. It might be an int. It might be a double. And then here, that's why I created this one, you put your arguments untyped in the parenthesis. And then afterwards, you put the arguments typed, 1 per line. This is also in XS Toot. So if you need to, and it's in actually all of the different XS documentation, but this is what that means. This is why they're doing that. So if you had multiple arguments to greet, you'd put them on another line after char star name. And if you have functions up here in the C line that you do not put down here in this declarations, Perl can't see them. So this is where you're saying, I have this function and you want to use this in Perl. But you may have other helper functions that you don't need. So now we have to use scalars. And we love Perl because we don't have to think about types. But this isn't Perl anymore, not really. So we have maybe some data, maybe it's an integer, and we want to pack it into a scalar. So you have to use a type-specific function to do that. It creates a scalar from what you have, but you have to do a different one depending on if you have an integer, if you have a double, if you have a float, a string. There are several different ways to make them from strings. I kind of like this one because you don't have to know how long the string is. It behaves like printf, but it prints it into a scalar. And then you can copy scalars this way. That's not references. There's a whole different semantics for references. And of course, you can use scalars as ints, doubles, strings. If you need the length out, you can get the length out. I think that's how that works. Shoot, I don't remember. Anyway, all of these are in Perl guts. And so what I'm telling you, oh, one more. There are plenty of other things in Perl guts. And you have, functions, actually this kind of looks like a macro maybe, that tells you, is that scalar true, like you do in Perl, but it's a C-level way of doing it. Maybe you want to cat some strings. Don't write your cat, string cat in C again. We have Perl. It's sitting there. It's just not quite as close. But we can still say, you're Perl, you know how to cat two strings, do it for me. And there's lots of that stuff. What I'm kind of trying to tell you in this slide is, you can still think like it's Perl, but you have to find the right function that does what Perl would do easily for you. And a lot of that's in Perl guts. But it gets a little bit better. When you have arrays, arrays don't take all the different types. They just take SV stars. So now you can kind of think of these even a little bit closer to how you think of arrays in Perl. They're filled with SV star objects. When you use them as an argument or when you use them as a return value, Perl sees those as array references, not as lists. So if you return an AV star, it's going to give you a scalar with an array reference in it. Keep that in mind. Unfortunately, here's where that little mortalization thing came in. The problem is deep inside of Perl. How much time do I? I'm good. Perl has a concept of array reference counts, and that's how it knows to clean up the memory when you're done. And a long, long time ago, someone messed that up. And because so many things rely on its current behavior, they can't fix it. And actually, I think they just did in 5.16 with a different macro, but I don't know that yet. I think I saw that pop up somewhere. But for now, here's what we have. And this is how I recommend you return multiple values in your baby XS. The other way to do it involves these stack macros. They're confusing. They're not that bad, but they're a different way of thinking. So what we do, we have some function foo. Can everyone read that in the back? I'm a little worried, but so we make a new AV star. I'm calling it ret because it's going to be my return. I guess I could have wasted a few more characters than that. And we have to fix the mortalization. They have this function, because they know this is a problem, which is SV to mortal. And basically, it post-decrements the reference count. Don't worry about that. It just makes sure that when you're done with it, it goes away. You have to cast whatever you have as an SV star. Don't worry about what that means. Just do exactly what I say here. SV star, parenthesis, ret, and it will fix that little bug for you. From there on, you can use this kind of like you'd use a Perl array. I have an AV push. There's plenty of other things you can do, but all I'm really telling you here is how you could return more than one thing. And I want to push onto ret a new SV IV, so a new SV created from an integer, and that integer is 1. And I want to create a new string, a new SV filled with a string, push it on there too. And now in Perl, when I get this back, it will be, like I said, square bracket 1 comma bar, close square bracket. But then I return that, and Perl will take care of casting that for me and doing those things. And that's really all you need. But you wanted to return multiple values. You didn't really want to return an array reference, unless you did, but maybe you didn't. And this is why I tell you to wrap all your C functions in Perl functions, for now. Before we get there, of course, you have to have a version. I'm pretty sure you have to. And there's a nice newer way of doing this that isn't quite so complicated. You require XS loader. It's core. It's sitting there waiting for you. And you just call XS loader load. That kind of assumes that you've had all the names the same. Don't change the names yet. But if you do, it's actually not that hard to play with. But for now, XS loader load. And all of a sudden, all those functions that you declared down at the bottom that were in the XS declarations are suddenly magically in your namespace. And you can use them just like they were Perl. So here I have a simple little thing. I wrap some args. This is some C function that returns an array reference. You pass the arguments to it just like you'd think you would. And then maybe I want to have some different behavior in scalar context versus list context. So if want array, I can return the whole thing as a list. If not, I can return one object or one scalar. You can do, of course, whatever you want here. The concept of my talk here is not do exactly this, but take that array reference back and treat it like you would now. Of course, in XS, you can do all of these things, but it involves lots of big macros, and maybe you just don't want to care. So it's really easy. Always return multiple arguments into an array reference, and then munge it back out when you're done in Perl, because we know that. And of course, you can export those functions if you feel like you should. Finally, you do have to pay a little attention to how you're structuring this. This, again, is assuming it's a module. You have a roof. Oh, and by the way, this is the structure as it would be in module build. It's only a little bit different in MakeMaker. I think it's, I'll comment on that in just a second. In module build, you'd have your lib directory and your Perl module as you would normally have it. Right next to it, you have the same name, but .xs, and that's where your XS is, of course. And of course, you have a build.pl. It's a pretty standard build.pl. You probably don't need to require a specific version. I do it because module build does a funny thing if you don't. All you need are these 3 lines, 1 line if you wanted to do it, where you require another core module, xutils cbuilder. That basically tells module build that I've got some XS here. Be sure to look for it. There are a couple other things you can do. Maybe I needed some library. So you can tell it extra linker flags, -l, some lib. I had -l GSL there in everything I write, but you might have something else. There are, of course, C flags, and there's other things you can do, but go find them in the module build documentation. It's pretty easy to find. And, of course, build script, because it's module build. As promised, I believe you, in MakeMaker, have all the XS files in the root level of your directory, but named the same way. I think that's true. I hope I'm not wrong. Look it up. It'll tell you. Use module build. Or not. And so that's all it really was. I have a few more things to say to you, but you're already done. You can already do this. And the code that I've shown you will work, and you can find it on GitHub. I'll tell you where in a second. There are a couple other ways you can do this, and they are actually both XS, but they do more of it for you. And particularly, inline C, if you don't want to make a module of this, if you just want to hook into a C function in your script one time, or but just for you, you don't have to distribute it. Inline C is really cool, and you write just the C function. It actually parses it back out, figures out what should have gone in the XS, builds your XS for you, dynamically links it in, and you can use it in that same script. Really cool stuff. And actually, even cooler, you can tell it to keep the XS laying around, so you can use that and then look and see if the XS that it built for you was. So if you are saying, oh, I'd like to write some module, but I'm still scared of XS, go look at what it built for you. And it's good for quick checks, too.
So if you save that, can you then use it later without having inline?
You can. You might want to clean it up a little bit. Yes. Well, I'm not sure I fully understand where you're taking that. But the question for the record was, can you keep that and use it again later? Is that what you're...
Basically, the question is, you say it builds and generates XS, and that optionally it can be kept around. Like, is it kept around as a file, as if you had written it manually, so then you don't...
It's kept around in... okay, so I understand now, I think. It's kept around in the same folder as your script, in a hidden folder, in some directory tree. And it will be reused if it's not changed. It's smart enough to do that. You can even use that to generate some...
and I think the main reason you export it like that is then you can use that as a starting point. You can use that to go bootstrap the XS you want.
Right, so go copy that from that folder to your own module directory and put it into the directory as it should have been, not how that module puts it for you. Just go grab the one.xs file from that if you want to do that. If you have more questions, I'm sorry, I'll have to ask you later because I might not be getting... and then PDLPP, if you're really working with numbers, PDL has a different way of doing this. It still also makes XS, but it does it nicely over all the PDL dimensions. If you don't know what I'm talking about, just ignore me. And that's it. Thank you to the people who sent me here. And my talks, 2 of them are down on this GitHub page. And this one is, of course, the one called Baby XS. When you get there, click on that. I'm effectively out of time, but it's the passing period before lunch. So do you have any questions?
Did you read the Simon Cousins has an extending Perl does XS stuff? It's 10 years old, but
So I do all of my Perl programming on the train. And so I've learned nearly all the Perl I know from Perl Doc. I haven't, and I've been told I should. And I've heard good reviews of it, other than it might be a little old. So, but I don't think XS has changed a whole lot in much of that time. How's Alien Base coming? Mac sucks. The other things are close-ish. But Mac all of a sudden it cares very much about where the library is. And if I move it, which I do, it cares very much that I change it. And because it's C, it only has so much memory for the string that represents it. So the thing I have to work on now is making sure that I have enough room in the created library to move it to somewhere else. Something that Windows does better than Mac. Okay.
What did you have to write?
I had to write a big differential equation solver, and I wanted C speed, not really C speed. The GSL is a really, really well-written library, and it has algorithms in it that I could never write or rewrite. So I wanted to do that, but I wanted it to take Perl closures and evaluate them as functions defining differential equations. So I had to get just far enough. It's actually not a huge module. If you go look, it's also in my GitHub. It's called Perl GSL DiffyQ. It's essentially the first one of these I wrote. It has stack macros. I have to use them, unfortunately. But I think that's the only rule of mine that I break. I break it a lot. But I actually have another one called text ASCII tech, and that one breaks a different rule of my one and doesn't break that rule. So go look at them. They're good. Text. Oh, no, tech. You're right. Tech, ASCII text. Something like that. It's on my GitHub. Go find it on my GitHub. It's cool. Anyone else?